Oh, it's okay. Okay. So good morning to everybody. So I'm Professor Emilio Silva. I'm chairing this workshop, strategic workshop on engineering grade challenges. So today our schedule is we're going to have now a presentation from, actually will be delivered by Professor Justo from electrical engineering at USP. Synthesis, where essentially he'll talk about the synthesis of the yesterday talks. And then after that we're going to have a panel discussion with all invited speakers. So I'd like just to remind you that we are being broadcasted through YouTube, okay? So I'd like to call Professor Justo to give a lecture about synthesis of the engineering challenges. Sorry.
Okay. Good morning to all present. Good morning to everybody who's watching on broadcast. Today, what I'm going to talk is what I call a wrap-up section. Let's see what we learned yesterday and if this makes any sense to us. So, our workshop is on engineering grand challenges. So we had some sponsors. We thank all the sponsors. We thank Escola Politécnica, Fundação Vanzolini, FAPESP, and Pró-Reitoria de Pesquisa, and especially Springer, which is our partner in this endeavor. Okay, we should thank our speakers, Professor Goldenberg from FAPESP, Professor Reddy from Texas A&M, Professor Shimonov from Purdue, Professor Aline from Urbana-Champaign, and Professor Lucio Soiberman from Southern California. And from our speakers, I put a single word from their talk, like a keyword. From Professor Goldenberg, keyword energy. Professor Reddy, design and analytics. Professor Shimonov, industrial processes. Professor Andre Aline, heat transfer. Professor Lucio Soiberman, data science. I'm sorry to you to say only in a single word, but the idea here for this slide is to say, does it make any sense to have a workshop with all different topics? Okay. With our classical way of thinking, it doesn't make any sense. Okay? But the idea is exactly that. It's bringing people to think different. Okay? We came here and we had a presentation, great presentation from Professor Knopf on Industry 4.0. And our problem is that we are talking about Industry 4.0 and we think 2.0. So when we look at these keywords, it doesn't make any sense. A workshop with all different topics. A typical workshop, we bring people together to talk about a specific topic. Not people talking about all different subjects. But what brings all those people together is not the specific topic that they're talking, but the problems and the challenges associated with these solutions and with these teams. That's why we come to the idea what brings together all these different topics. And from my question, does it make any sense? Okay, if you look at the previous set of keywords, it doesn't make any sense. Now, if we think about what we call 14 Grand Challenges of Engineering from National Academy of Engineering, American National Academy of Engineering people, senior fellows brought together what they call 14 Grand Challenges. And when we think about those speakers and the solutions they propose, now it makes sense. Okay, because if you look at what we call 14 Grand Challenges, if I challenge any of you in the audience, any of you watching on broadcast, what are your grand challenges? I'm sure that anybody could bring a list of 14 grand challenges. Anybody could bring a list of, say, I want 15, I want 14, I want 16. Doesn't matter. What matters is, if I give you the constraint, what are the grand challenges for human survival? I'm sure that most of those lists will have more or less this kind of ideas. Ideas associated to, challenges associated to carbon sequestration, shortage of water, energy, infrastructure, virtual reality, learning. And what brings those people together, those invited speakers here, more or less, if you took a look on their presentations, what is in yellow here was discussed somehow by most of those speakers. So what binds this workshop is not a specific subject, but how we put together those specific subjects to solve great problems, important problems, global problems. So it's an opportunity more than looking into those challenges, but reflecting how we are thinking about doing science, how we teach science, how we publish science, how we report our results. And that's the whole idea that I'm trying to challenge you for the next section. I'm not coming here with any answer because, first of all, I don't have the answers. And second, my idea is that to make you invited speakers in the next panel, give me some answers. Okay? Okay, now I borrow some quotes from the speakers. I took note in my notebook, and I'm sorry if I didn't choose the best quote that you would like to put there, but the quote that I thought it would be important for my goal of my lecture make any sense. Okay? And then I from Professor Reinaldo, the vice director here, who came with the quote, complex problems require complex integrated solutions. Professor Gondenberg, we need more energy and use it more efficiently. Professor Reddy, improve our knowledge on what we already know, on analytics. Professor Shimonov, the area of collaborative automation and cyber convergence. Professor Elin, very important, learn to compromise on design. And from Professor Lucio, I borrowed an important sentence. We needed sociologists and psychologists. When we look at those sentences, and we look at the previous slides, what are our challenges? We see that our challenges are complex, involve several areas, okay? And we need to look into those problems in a different way. So some keywords that are not necessarily spoken specifically by anybody of you, but we could bring together for our next section. First of all, our problems are global. Think about the problem. First of all, understand it deeply. Understanding the problem is already a major challenge. Another important sentence that was put here is that areas and fields are human constructions. Problems are not from a specific area. Sometimes we go to a seminar and say, oh, this is not my field. I don't need to watch this seminar. Okay. We are thinking 2.0. So we need to think more deeply. So we build areas. We teach in specific areas of engineering. And probably not, certainly, the problems do not choose specific fields. Solutions require collaborative work of people from different backgrounds. Then I took the quote from Professor Silva that he needed at some point some sociologists and psychologists to understand the technology and making people use the technologies, not only developing the technology, but convincing people to use the technology. Solution, okay? We need to change our culture of doing research, teaching, and reporting our results. And that's the major sentence that I would say that brings us here. No technology is useful without addressing all the way the questions from fundamentals, design, manufacturing, social and environmental impact. We cannot think anymore that the technology is something that I developed in my office and that's it. We need to think globally. So I borrowed one specific slide from Professor Allen, the elephant puzzle. Actually, that's what I'm saying, that we think 2.0. We teach civil engineering. We teach electrical engineering. Somehow, we are looking at the rope. We are looking at the T. We are looking the elephant puzzle very closely. We do not know that's an elephant. When we say that we need to think 4.0, we need to think 4.0, and we need to start making changes to teach 4.0. We need to start making changes to report our results 4.0. Okay? So the elephant puzzle means that we need to look into the picture that's for sure. It's fine that someone knows that that's a rope. It's fine that someone sees that as a fan. It's fine. We need people with that background. But we also need people to solve the problems that look that farther away and say, that's an elephant. It doesn't mean that we only need people to look far away from the elephant. We need all those people with different backgrounds. And to have people with those backgrounds, we need to teach people to have those backgrounds. And if we say that the next generation of young guys will make this transition, we must make this transition to teach those people to think that way. So, I would say that somehow the elephant is here in the room. That I borrowed this sentence from a colleague from Lucio when he was in Carnegie Mellon, Professor Randy Pausch, who died and gave the famous last lecture. If the elephant is in the room, introduce him. And the first thing that we are trying to do here, and that's why it makes sense to bring all those people, those invited speakers, more than thank them to come here to give a talk, is thanking them to believe in this different idea of thinking, doing science, and reporting science. So the elephant is in the room, so solve the problem. And the idea that comes around from this workshop was to present a new journal with a different perspective, not from full papers from specific results, but a journal that could drive people to think about knowledge looking the elephant, not looking into the specifics. So that's why I thank the speakers for not only giving the talk, but believing in this idea. Okay? So I thank you, and I hope this presentation gives you some elements for the next section.
So, you want to make some questions or open the discussion? Okay. So.
Does that mean you have questions? Okay.
Oh, we can.
We can have questions. The questions goes to the next section.
Good morning. I just want to congratulate the organizers for this event. I work in the metrology field, so we deal with physicists, with engineers, with economists. So as a scientist that I have to deal with the elephant all the time, I'm very happy for this event, and I'm really excited for the journal. So it's very hard to publish multidisciplinary studies and we have so many specific journals. So I have published recently in Journal of Physics and blood pressure measurement journals. So basically the same study with different results. So this journal is a very good way to deal with the multidisciplinary issues that we have in science today. Thank you a lot.
Okay. Oh. Also.
Probably a lot of people will be asking themselves how would be the process for this journal, because we already know how is the process for a specific journal. So you have people submitting papers in a specific area. You have people, expert people, analyzing those papers from the same specific area. But now, how things are going on?
This question,
you mean you're asking specifically about?
For instance, the process of analyzing and accepting paper, because you have multiple areas. So how?
Oh, okay. I mean, once the article is submitted, we assign it to the associate editors, and then we have the policy. The reviewers, we must foster the diversity of the reviewers. Okay, in terms of, the editor, we will analyze at first the content of the article and see which areas are involved, let's say, in that article, and select the reviewers that can see, I would say, the different points of this multidisciplinary action. So I don't know if I answered your question. So it follows the traditional way of doing reviews in journals. However, we have to be selective with the reviewers, because you want to see different aspects from that specific article.
Yes, but don't you think even composing expertise, you have to require from the reviewers that have the same spirit that was presented here? Otherwise, it'll be compose is not enough. Yes.
Sure. It's not easy to find. I would say find people like that will have this kind of view, right? So in the sense that, but that's the challenge that you have to face. Okay. Okay. So, okay, now we are supposed to have a coffee break here now, right? And after the coffee break, let's make it short. Then you're going to have this panel discussion with all invited speakers, okay? That is going to be mediated by me and Professor Reinaldo Silva.